Hello. We start a new chapter. By the way, I hope you had a good luck in the midterm exam. Now I'm recording this while you are working on the midterm exam. So, in the first four chapters, we studied regression models and basics of the regression models with a single regressor or multiple regressors. And also we learned how to implement the OLS estimation and how to measure the goodness of fit and what are the required assumptions and how we implement hypothesis testing and calculate the confidence interval. So so they are literally the basics. And in this chapter, we are generalizing. We are going the breaking through out of the setup so that the regression model is now nonlinear. So let's start. It will be very brief today. So we assume that the regression function is linear in the regressors, which is a very powerful simplifying assumption. So, like because of the linear assumption, the estimation is simple, the presentation is simple, interpretation is simple. However, so linear approximation and the linear regression assumption is okay in I think like more than 90% of applications, but in some cases, in some cases, linear assumption is not okay. Like it can be restrictive, and so you need to relax that assumption to better explain, better capture the relationship between the outcome and the regressor. Here's an example. In this case, this is an example where linear assumption does not cause much problem. So when you make a trend line like this, it looks like quite symmetric across the line. So the above the line and below the line are pretty much like symmetric to each other. So in this case, I think it does not have much problem. Linear assumption is okay. However, this is the problem. So if like this is income, school district's income, average household income, and the average test score. So first, it is clear that as the school district average household income increases, the test score of that school district would increase. That is that is like intuitive. It's anyone can think about that. But is it a linear function? That's a different question. Like it is not terrible. Linear function is approximate explaining like this. However, the problem here is above the line and below the line have systematic difference. So above the line is like here and below the line is more to the left. So that means it would have been better if you used nonlinear function like this. So just from the graph, I would draw a line which is a curve. So like if you can draw a line like this, so increasing fast and then slow down, slow down, slow down, flat. So that would be a better fitting line than a straight line. So then what is the intuition? Also, it is economically intuitive. Think about this. Suppose that I give you, say, think about the stimulus check. Suppose that $1,000 is given to a household. Say $1,000 is given to a household whose income is only $5,000. Then the stimulus check would have a huge impact on the household's performance in general. Like they will better take care of their kids than before, and they can like have more leisures and better nutrition, and so better transportation. So everything will be better because their income increased by 20%. So $5,000 income plus $1,000. So the effect is pretty steep. So additional $1,000 has a greater impact. However, think about a household, say, who is already making $100,000. So I'm making $100,000 and I additionally get $1,000. Then my income increases by only 1%. Then this additional $1,000 may have no impact at all. I must have been like taking care of my kids already the best I can do, or I have no shortage of any money. So my life quality, living quality, would not be affected by additional $1,000. Then then clearly it means that the slope here, slope on the lower income should be steep, but slope on the affluent households must be flat. So steep and flat. So the slope is not just straight line. It should be something like this, like this. So this is a clear example where the scatter plot implying a nonlinear relationship between these two variables. So, but still, you can do a linear regression model here, just it is not the best. So you can do nonlinear analysis without much difficulty. So then let's think about what the nonlinearity implies. As I said before, the effect on the outcome, say test score, or I would say living quality. Your living quality the does not increase, like, so the effect on living quality of the stimulus check depends on the value of the income. So additional income, the effect of additional income depends on the value of the existing previous income. So if I'm a billionaire, like additional $1, nothing. But if I'm a homeless, then $1 must be very valuable to me. So the marginal effect is not constant anymore. The slope may change at different points. So steep, and flatter. So then in this case, if you use a linear regression equation, we say that your model is misspecified, wrongly specified, and one of the assumptions is not satisfied. So we call this misspecification problem. And simply, one of the assumptions is wrong. In this case, the functional form is wrong. The functional form is wrong, so causing a misspecification problem. And as a result, because of the misspecification or a wrong assumption, wrong linearity assumption, the estimator will be inaccurate, biased. It may be. So as you can see here, so the effect of stimulus check for this household is overestimated, but underestimated here. So true effect is steep here, very steep here, but your estimation is like this. So underestimated. But here, the true slope is flat, but your estimated line is steeper. So also underestimated, overestimated. So as a result, this is all because of the nonlinearity, or the truth is nonlinear, but your assumption is linear. That is the problem, and so what it says in general, it isn't even right on average. Means here we are underestimating here and we are overestimating here, but their average is not zero. So maybe you may you may argue that you are overestimating somewhere and underestimating elsewhere. Then overall they will cancel out. That does not work. Mathematically, that is not the case. So in any sense, the bias is a result. And the solution is to use a nonlinear function. So the solution is simple. The problem arises because you are using linear function. Then why not using a nonlinear function? This is the very general nonlinear regression function without any functional form. Just say outcome y, test score, say test score is a function of student to teacher ratio, percent of English learners, and say household income, plus errors. Errors is added later. And so the relationship here in this function is unknown. It may be linear, may be nonlinear. It's just a general representation. And the assumptions are the same, even if it's nonlinear. The assumptions are basically the same. First, there should be no systematic difference in the errors, and the observations must be IID, also the same, and no rare outliers, also the same. So all of these guys are the same, and also no multicollinearity. Multicollinearity also in the same intuition. However, even if I said they are the same, but there are differences in mathematical derivations and mathematical statements. So I'm only saying that your intuition can be maintained, intuition survive, but the mathematics, which I do not derive here, mathematics details are different. So like later, if you take another course or if you go to a graduate school, please then you need to understand the minor differences in mathematical details. That's not covered, not considered here. And in this case, another problem here is how we measure the effect of one regressor on the outcome. When everything is linear, it is simple. The effect is measured by the slope. However, when you have a nonlinear regression, it has to be defined this way. Suppose that x1, you are interested in the effect of x1 on the outcome y, and suppose that x1 increases by delta x1. This triangle is Greek letter, capital letter delta. So if x1 increases by delta x1, then the y increases by delta y. So delta y is obtained by the difference between before the change and after the change. Everything else being the same. So x2 through xk are held fixed, but x1 before x1, after x1 plus delta x1. So their difference will be the expected, the effect of x1 on y. Exactly, this is an extension of the linear slope. So, okay, we will discuss what are examples of these nonlinear functions and how we interpret the slope, the effect, marginal effect in the next video.